Hello. In this video we're going to take a look at generics, and we're still working in the scene that we were previously working in, where we're changing between different scenes. We're going to take a look at how generics work and how generics can apply to extending your monobehavior class to add some functionality and features to it. So let's open up the sound manager again, and what we're going to do is we're going to create a generic. Now, you're probably familiar with generics to a certain extent. If I were to say, like, let's see here, let's see, game object dot get component. Actually, let's try it with the lowercase g. So game object dot get component, right? You get these pair of angle brackets that come up, and we would look for a component like audio source. So I'll say audio source, and this is basically a generic. So it's passing this generic data type to it, to this get component function, because this get component function receives multiple types of data. It might be getting an audio source, it might be getting a rigid body, it might be getting a string, it might be getting a integer, and what this generic allows this function to do is accept multiple types of data, and that value can get set by the function when it gets called. So it makes it really efficient at being able to process whatever you want it to do. And with our singleton pattern, we're going to want to be able to pass whatever class we create to it, so that it extends its behavior and will only be that one particular instance of it inside of your game. So that's the kind of functionality we're trying to add in. So you have to use a generic in that case, because we never know what that object could be. It could be a game manager, it could be a sound manager, it could be an inventory management system, that we would want that only that one thing to persist throughout the game. So in that particular situation, we would use a generic. So I'm going to delete this code that I just created here. And we're going to start this off by creating a function that accepts a generic value. Okay, so I'm going to create a public function here, and I'm going to say void, and I'm going to call this console message. What we'll do is we'll just print out some stuff to the console in this example. So console MSG. And console MSG is going to have a generic of T. And we usually use T to define what the type of generic would be. It's just a generic letter for type, but you could basically call T whatever you want it to be. It doesn't matter, but it does get referenced throughout your code once you declare it here in the function declaration. Then in your parameters, you would say T is a value. And what value means is that it could be anything. Whatever value we pass to it, we're going to want it to handle that value in a specific way. Okay, so I'm going to create a set of curly braces here, and I've got the set of curly braces, and we're just going to do a simple debug function. So debug.log, and what we're going to do is we're going to debug a message. So we'll say the message is, and then we'll add to it whatever that data that we're passing to this function that accepts a generic is. So the message is, and we'll add to this value dot, and we'll do toString because we want it to display as a string. This thing needs to be a string to display inside of the console. Now toString is a function, so I need a set of parentheses after toString there, and that'll get rid of the error that was showing up. Alright, so how do we call this thing once we create it? So let's look at some specific examples. We'll go into the start function here. Let's put a comment calling a generic, and let's see here what could we do. So what I'll do is I'll have it pass it a message. So I'll say console MSG, right? And console MSG is going to say it's going to get a generic type. So when you want to type this, we're going to want to pass maybe like a string value to it. So I'll say string. So the type of data I'm going to send is a string, which is going to be a message. And then inside of the parentheses is where I'll pass it the message that I want it to display. So I'll put in a message and I'll say Jordan is awesome. Alright, so it says Jordan is awesome. So if I save this, right, and I start this up, immediately it'll call this function and pass that data to it. So let's go back to Unity, make sure you saved your class there, and if you hit play, you should see the message at the bottom that says Jordan is awesome. Now, you might be saying to yourself, well, what's the big deal? I could have just made that a string, but the whole point of this generic is that we can send any type of value, and it will treat that value however we would like it to be. So in the case of our singleton pattern, we want to be able to pass any type of class to this thing, and it'll treat it as however we want it to treat it. So we'll do a different example. Instead of passing a string, what we'll do is we'll pass an integer. So I'll type in console message. I'll label this as an integer, right? And what I'll do here is I'll pass a number to this. So I'll pass 9,000. Okay, so what it'll say when this prints it out is the message is 9,000 because it's going to take whatever that value is and convert it to a string. Alright, so if we save this, go back to Unity, and hit the play button, we see the message is 9,000. Oops. And if I open up my console, let's pause this real quick so we don't have the audio blaring. We get our first message and then our second message. So we're using that same function with two different types of data, two different classes of data, right? Now our singleton pattern that we created here, what we can do, I'll shut off play mode here, is take this pattern pretty much that we created and pass instance as a generic to it into a separate class. Okay, so let's create that class. We'll start off by creating that class, and I'm going to show you how you can extend this using inheritance here. So I'm going to hit the plus sign, and I'm going to create a new C# script and call it singleton. I'm calling it script instead of singleton. So singleton, and I'll open up singleton here. Didn't open it by default, so open it up. And now that we have singleton open, what we'll do is we'll start getting this thing set up. So the first thing we need to do is set this up so that it accepts the singleton, the generic, and extends it for mono behavior. So up in where it says, up at the top where it says singleton class, we get the namespace for mono behavior that we are inheriting from, right? So what we're going to do here is add a generic here. So T, capital T like that. So it's going to say singleton T, mono behavior, right? Colon mono behavior, where T inherits from mono behavior, like that. So what it'll do is it'll accept whatever class we say T is into this function so that we can then utilize inside of this class. And it'll become an extension of whatever class calls this singleton pattern. So not only will it get mono behavior, it'll also get this new pattern that we're adding to it. So the first thing we need to do is create that public static variable. So we'll create a public static, and the public static is going to be that generic T that we passed to it. And what we'll do is we'll call this instance, just like we did in the Sound Manager. Now I'm going to add a shortcut here for getter and setter. So I'm going to type in get, semicolon, and then set, semicolon. Now what this does is it's just basically shorthand for saying if we call this instance, we're going to get it. And if we're sending information to this instance, we're going to set it. So it's going to return the data that we need when we call on it, and it's going to set the data when we tell it to set it and instantiate it. Okay, that's all this piece of code here means. The next thing we can do is we can actually get rid of the update and the void, the start and the update function. We're not going to need either of those here, but we are going to need an awake function. And what we're going to do here is we're going to create what's called a protected, and you don't have to do this, virtual. Protected virtual. So what the protected virtual does is it will protect the data, meaning it will only be visible within the class, and it can only be overridden by whatever class derived it. So whatever class it was instantiated from. And that's all it is. It's a way of protecting it and maintaining this particular pattern to whatever class sets it as an instance. Alright, so protected virtual, and we'll do our regular void awake function. And from here, what we're going to do is set up our singleton. So what we could do is jump back into Sound Manager here. It looks like I'm missing a curly brace. I deleted an extra curly brace there. I'm going to go back to the Sound Manager, and I'm just going to cut out everything that was inside of here. And then delete this awake function. We're no longer going to need it. And if I jump back into the singleton pattern, I can paste this in here. Now we're going to make a couple of changes here. So for instance equal to null, we can't set it to this because we don't know exactly what object it is. So what we're going to use here is a function called find objects of type, or find object of type. I'm sorry, there's objects and objects. So find object of type, and we're going to look for t. Alright, so it's going to set instance to whatever t is in this particular case. Actually, we should do it this way because it's a generic. So t. We're then going to destroy whatever the game object is if it's already existing in the scene. And then inside of our don't destroy on load, what we'll do is we can copy this find objects of type t and paste it over game object here. And I think that's pretty much it. That's all we're going to need for this particular class. So how do we implement it back inside of our Sound Manager? So I'm going to save this and head back to the Sound Manager. And instead of inheriting from mono behavior, what we're going to do is we're going to inherit from that singleton class. So we're going to delete mono behavior here and type in singleton, and we're going to pass the singleton our generic of Sound Manager. And what that's going to do is it's going to inherit those properties of that class and make it act just like it would if we had that code. So now instead of having to write that code in anything that we want to be a singleton, we can just make it a part of that class by grabbing the data from up here. So hopefully you kind of understand this and you see why this is useful, because it could really help speed up your game development time in the future. You could just take this singleton class, bring it in, and then boom, set it to whatever you're working with inside of your other game. So I'm going to save this and then head back to Unity, and I just want to make sure that this is still going to operate the same way. So I've got Sound Manager here. Everything seems to be set up the same way. We're going to hit play. change the scene, and looky here. Don't destroy outload sound manager. So it's still operating the same way it was before. I'll make sure that all the files are saved, and yeah, it's working perfectly. So now that we have that singleton class set up, we can start setting up a game manager that data can persist from scene to scene to scene. And this would be a way that you could manage, how much your player has scored during their gameplay session. You can, maintain inventory and then save it out after they close out of the game. You can also manage the different game states, whether they pause, whether they quit, whether they, jump to a different menu screen during gameplay. It has a lot of flexibility because it can exist in all of your different scenes and be able to access all the other parts of your game. It's able to touch all the different parts of your game. So it's an important aspect of what we're going to be building here. So in the next video, we're going to be taking a look at game managers.